Hello everyone, I am K.Harshith. In my previous video, we have discussed about alkanes. Now let us have a summary on the alkanes once again. So alkanes, what the general formula of alkanes was CnH2n plus 2. The general formula of alkanes is CnH2n plus 2. We took the value of n as 1 and we got C1H 2 ones are 2 4, and we also learned how to name the compounds. If it is having n as 1, then we would put the word root as meth and the suffix as ane, methane. Similarly for 2, we will be writing C2H 2 2s are 4 6. For second compound, we would be writing it as ethane. Then N is equals to 3. C3H 2 3 is 6 7 8. 3 means prop and ane. Then N is equals to 4. C4H 4 2s are 8 9 10. C4H10. So if you see for carbon, number of carbon atoms 4, we have the name as but and then ane. And then N is equals to 5, C5H12, and the name would be pent, and then it would be hexane, septane, like that it would be continuing. Now if we see here, it is methane, ethane, propane, butane, pentane, and the general formula, if you see, these compounds are having the same general formula, that is CnH2n plus 2, which means now these are having the same general formula, but if you see the structures, they differ. For methane, the structure would be like this, C and then 4H. For ethane, it would be like this, C 1 bond 1 2 3 1 2 3. For probe, it would be like this. The arrangement of hydrogens is different in each case, means they are having the same general formula. The general formula is same, but the structure is different. So if the compounds are having same general formula but different structures, then we would say those series as homologous series. Homologous series, we are talking about alkanes. So homologous series of alkanes. What is the name? It is homologous series of alkanes, which means it's having the same general formula but different structures. So they are called as homologous series of alkanes, and these are known as homologs. Okay, so now we saw that methane, ethane, propane, butane, and pentane are homologous series. Now let us see some characteristics of theirs. Now, if we see some characteristics of homologous series. Now, first let me take methane and ethane. The formula is CH4 C2H6, CH4 and C2H6. Now, now try to subtract C from C2 from C, we get C, and H6 from H4, we get H2. Means the difference between the two homologs in a homologous series will have a difference of CH2. Now you see here, it is CH4 C2 C2H6. The difference is CH2. If you add CH2 to CH4, we get C2H6. Similarly, between these two, we have a difference of CH2. C2 3 6 7 8. and these both also CH2, these both also CH2, and then next coming hexane, septane, they also have the difference of CH2. Now how we got here? We are just subtracting the number of carbons from the previous one with the first one. So we are getting one carbon, two hydrogens. Now this is about the difference in their carbon and hydrogen atoms. Let us see the difference in the atomic masses. Now if you see, now let me take the atomic masses of these compounds. Carbon's atomic mass is 12. The atomic mass of carbon is 12, and then the atomic mass of hydrogen is 1. But we have here 4 hydrogens, so 4 into 1. 12 plus 4 is 16. The atomic mass of CH4 or methane is 16 AMU. Fine? 16 AMU. Now let us see for ethane. Ethane, you see 12 of 2 plus 1 of 6. 12 2s are 24 plus 6. We get it as 30 AMU. We get the atomic mass as 30 AMU. Now you try to subtract 30 AMU from 16 AMU. AMU means the atomic mass unit. AMU means the atomic mass unit. Now when you subtract, we get a difference of 14 AMU. With a difference of 14 AMU. Now if you see between these both, there is a difference of 14 AMU. Between these both, 14 AMU. Between these both, again 14 AMU. Again these both, 14 AMU. Now I can say the homologous series of alkanes, the homologs in the homologous series differ by a formula of CH2 and atomic mass of 14 AMU. This is the first characteristic that can be noted. The homologs differ, the homologs differ by formula of CH2 and mass unit and mass unit of 14 AMU. The mass unit of 14 AMU. Now I hope you have understood how we got 14 AMU and CH2 here. Now let us come to another characteristic of the homologous series. Now let us see the another characteristic of homologous series of alkanes. They have similar chemical properties. Similar chemical properties, because only we are having carbon and hydrogen, so we would be having only the chemical related to carbon and hydrogen, so the chemical properties of the homologous series would be same. But whereas coming to the physical properties, they have different physical properties. Why? Because if you see, the arrangement of carbon atoms would be different, the number of hydrogen atoms would be different. Now see, methane would be like this, C1H4, ethane would be C2H6. Now as the number of carbon atoms are increasing, the physical properties will also vary. The melting point, the boiling point increase with the increase in the number of carbon atoms. Now methane, ethane, which will have more boiling point? Ethane, because ethane is having more number of carbon atoms compared to methane. But if you take propane again, propane Propane would be having more than ethane because it is having more number of carbon atoms. Now butane, it would be having more because it's having more number of carbon atoms than propane. So like this, as the number of carbon atoms keep on getting increased, even the melting point and boiling point also increases. We only take that on the basis of the carbon atoms, number of carbon atoms. We don't check the number of hydrogen atoms. So we saw the three properties of homologous series. That is, the homologous series differ by a formula of CH2 and a mass unit of 14 AMU. And then they have the similar chemical properties because they are having only two compounds, C and hydrogen. And then they will be having different physical properties as the arrangement of hydrogen and carbon atoms are different, and as the number of carbon atoms as the number of carbon atoms increase, the melting point, the boiling point also increase. The symbol of this means increases. As the number of carbon atoms increase, the melting point, the boiling point also increases. Another point that can be added is the homologous series of alkanes are also known as paraffins. And all these compounds are obviously saturated, which means there is only single bond between them. Saturated we learned, right? Saturated is nothing but single bond. Unsaturated means double bond and as well as the triple bond. So that's it for today. We have learned, now in this video we have learned about the homologous series. What is a homologous series? Then a homologous series of alkanes. Then we learned what are the characteristics of homologous series of alkanes. I hope you are clear with the concepts that I have taught today. Thank you.